Okay, so I want to talk about these comparators because we took a peek at them yesterday, but I want to go into them into a little bit more depth. The idea is that there's an interface called sorted set, which is a type of set. And like all sets, it can only contain unique items. And what is meant by unique is kind of a combination of the equals method and the hash code as far as sets go, as we've seen with the hash set. With sorted sets, there's an additional comparison that needs to be made. And that's because whenever you're sorting anything, you need to decide if I have two things, which one is bigger than the other, or are they equal? So by itself, a sorted set can only contain objects of a class that implements the comparable interface. And that's because the tree, by default, what it does is as you put objects in, it's actually under the hood putting them into this tree data structure, but where it puts it is what determines the order that they're in. So for example, if you put in let's say you have a collection of integers and we're just using the default sorting. By default, the integer compared to uses the value, smallest to largest. So if I'm comparing two integers, if they're equal, then they're equal. If one's smaller than the other, then it goes first. And so the tree set uses this compare to method with everything, but only if you haven't given it a custom comparator. So the custom comparator comes is what if you want to sort it differently. So even if it's comparable, if I want to sort the integers in reverse order, as we saw yesterday, then what I do is I write a custom comparator, and then when I instantiate the sorted set, which in this case is going to be a tree set, I pass it an instance of that comparator, and the tree set will use that comparator rather than the default. Like the compare to method, it needs to be, it has the comparator. In the comparator, you give it two items and say, is the first less than the second, or greater than the second, or are they equal? And again, like the compare to method, since it's since it's written in code, and code either stands a chance of not being correct. An incorrect comparator would, among other things, violate this. In other words, if I say this is bigger than that, then that has to be smaller than this. So in other words, if I flip the order of the two arguments, then I need to get the negative. And on the slide I say -1 and 1. That's, strictly speaking, it's just anything that's negative. So it doesn't have to be just -1. It can be any negative number. And likewise, it doesn't have to be +1. It can be any positive number. Okay, we saw one example yesterday when we did the integers the other way. So I want to give two specific examples here. That's one. Okay, so maps are generalizations of arrays. Now here's one way to think of an array again. An array is a mapping in the mathematical sense from an int to a value. And as we've seen, arrays can have values that are primitive or objects. The other constraint is that with an array, the possible values for the ints must be 0 through n minus 1, the silly zero-based indexing. So the question comes up, or at least the situation comes up, is what if we want to have the same kind of mapping from some key? So we can think of the integers in an array as the key and the particular items in the array as the values. So you put in the key, say index 3 of the array, and it gives you back what the value is. And that's what's known as a map. So there is a class, or actually an interface called map, and the idea is that the key now can be any object, and the value can be any object. And in this case, unlike arrays, the values have to be only objects. The other constraint that we had, was that in an array there has to be the indices in order 0 through n minus 1, whatever that length is. We can't skip any. So, think about supposing we have a bunch of movie objects, and we want to store them by year, for example. So we'd have, one for 1945, one for 46, whatever. They would be contiguous, but there were no movies in year 0. And as far as I know, the first movies weren't until like the late 1800s. So if those are, I think those are in the database even, some of those. But it doesn't start at 0. So if we only had arrays, then we would have to have a bunch of arrays, say 0 through 1895, that would just have nothing in them. So instead, we can create a map where the key is, say, the year, and the value is the value might be a set of movies that were made in that year. Now, the only constraint is, unlike an array where we have to have contiguous integers from 0 up to the length minus 1, the keys can be anything, but the only constraint is that they have to be unique. In other words, I can only have one 2010 in the keys. I can't have two. And if you think about it, that should make some sense, because if I am allowed two keys and I say, give me the years in 2010, and it's got two entries for that, then which one is it supposed to give you? Okay, there are three implementations of this. One is, and the difference is what kind of set is used as the keys. So the fact that the keys have to be unique suggests that using a set for the keys is a natural way to go, because sets can only contain unique objects. So there are three implementations, and the name of the implementation tells you what kind of class is used as the keys. So the hash map, the keys are a hash set. Now, since a hash set can have the order just be arbitrary, then if you don't care about the order, then they can get all mixed up. And by mixed up, I mean there's no natural order to them. On the other hand, there's a linked hash map, which I haven't really had much use for, to be honest, but is possible. And since the keys are a linked hash set, they will be kept in the order that you put them in. Again, that's, I haven't found that to be terribly useful. But the third is a sorted map. And the keys are in a sorted set. And the implementation is a tree map. So that concrete map, the tree map, implementing the sorted map, uses a tree set as its keys. And that's how you can keep them in order. So in other words, like these movies, if we're putting them in and the order that the database that we're reading them from just doesn't have them necessarily in sorted order the way we want them to, but let's say we want to keep it in sorted order according to year, then if we use a tree map to do that with the year as the key, then that will keep the years in ascending order. And that's often something that we want. It isn't 100% necessary, but in many cases that's kind of what we may desire. So how does this